All right, y'all, welcome to section 3.6. I'm very excited for this. It's going to be what we're going to do today is going to be a culmination of just a whole lot that's been going on. And I'm going to preview one of your Desmos slides from class right here and right now. Solve by completing the square. What is the next step? Literally, A, B, and C have actually no numbers here. We're going to really just use A and B and C, and we're going to complete the square. We've been working on completing the square for the past 3 lessons, and here it's just all going to culminate, and we're just going to see what happens if we're not given any numbers. Check this out. All right, so let's get rid of that A value first. In order to do that, we are going to divide all the terms on both sides by A. And when you do that, you get x squared plus b over a x plus c over a is equal to 0. By the way, you don't have to write this down. You just have to check out what's going on. These are not part of your notes. Let's see. We need to get it into x squared is equal to something times x is equal to something. So I think we need to subtract from both sides c over a. Let me move my head over here. Let's see. Then we're going to have to calculate some side work. We have to figure out what will complete the square. I think what we have to do is you take b over a and cut it in half, or by multiplying it by 1/2, and then squaring that. If you do that, you get b over 2a, and when you have to square it to get rid of the parentheses, you get b squared over 4a squared, and that's exactly what we should add to both sides. Add. All right. So here we've added b squared over 4a squared to both sides, and I think what I want to do next is combine these two fractions. And in order to do that, we have to get a common denominator. The common denominator is going to be 4a squared, so we have to multiply both the numerator and the denominator of this tiny little fraction by 4a. If we do that, we get 4ac over 4a squared. And there it is. Now we've got common denominators. We can combine fractions together. And there it is. All right. Let's change the left-hand side, this trinomial, and let's factor it, because it is a perfect, we've arranged it, we've forced it to be a perfect square. Let's factor it like this so. And so we get x plus b over 2a squared. Remember, it's the square root of this, and it's 1/2 of this. Is right here. If we wanted to FOIL this out, we'd go from here back to here. So it works. Now that we have a perfect square, let's take the square root of both sides. And wow, although the left-hand side is getting simpler and simpler, the right-hand side is getting uglier and uglier, or more complicated, more interesting. We have to remember the plus or minus, and then we take the square root of this whole big honking thing. But I think, looking at this denominator, I could take the square root of that. So what I'm going to do is I'm going to split up the square root into the square root of the numerator over the square root of the denominator, like this. Okay, so there it is, and we can actually take the square root of 4a squared. We can simplify that denominator, and there it is. Now we are on our quest to get x all by itself. So let's to solve for x. Now remember, that's what completing the square. That's why we complete the square in the first place, is to solve for x. Let's subtract from both sides b over 2a. And that's what we get. And look at this. The denominators are both the same, 2a, 2a. These are two fractions, and let's combine them together. So we are left with x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Cue the minute montage.
X equals negative b plus or minus square root b squared minus 4ac divided by 2a. 2a! 2a! 2a!
Quadratic formula is a breeze. Identify A, B, and C. Then you gotta plug them into the formula begin by setting it up. Here's how it goes. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you know the way to present text with an A.
Negative b plus plus or minus the square root of b squared minus 4ac over 2a.
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Ever since I learned this way to solve, I've got a reputation for my math now.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
All right, y'all. So this is section 3.6 using the quadratic formula and discriminant. I hope you enjoyed that minute montage. The big idea that I hope you're getting is that you can solve any quadratic equation you want using this formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I remember it using Pop Goes the Weasel. If you got a better song, then go for it. But otherwise, it's one helpful way to remember it. And oftentimes on quizzes, I'll get students who are like in the middle of it. It'd be dead silent, and they're all working on their quiz. And then one person will be like, x equals negative b plus or minus, and you can hear it, and it's fine. Let's just let it go, because that's what people need in order to remember it. So we're good. X squared plus 5x plus 6 equals 0. So this is just some random quadratic formula. There's nothing special about this, but what you can do is you can take, if you identify what the a value is, the b value, the c value, that's 1, 5, and 6, you can plug them into the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then all you got to do is simplify it, and those are your answers. Simplifying it can be kind of tricky sometimes, so just be careful. Show your work. 5 squared is 25 minus 4 times 6 is 24. 25 minus 24 is 1. And that's negative 5 plus or minus 1. When you add, you get negative 2. And when you subtract, you get negative 3. That's it. Here, x squared, let's see, a is 1, b is 4, c is negative 17. And so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Plug them all in, you get negative 4 plus or minus the square root. Let's see, this would be 16 minus a negative that turns into plus a positive. Plus 4 times 17 is 68, so 16 plus 68 is square root of 84. Now, in this particular question, they're looking for you to round your answers to the nearest hundredth. So that's what we're going to do. We'll plug that in, we'll type it out. You can imagine a world whereby that you have to do a whole bunch of simplifying. If you want an exact answer, simplify the radical, but we're not going to do that right now. We want answers to the nearest hundredth, and that's what we're going to give. 2.58, comma, negative 6.58, depending on whether or not you add or subtract. Here, a is not 1. All right, moving right along. We got 3x squared minus 5x minus 1 is equal to 0. A is 3, b is negative 5, c is negative 1. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Simplify that, this becomes a positive 5. 25 minus what turns out to be positive, 25 plus 12, because the minus and the negative cancel. 25 plus 12 is 37, and then you get 5 plus or minus the square root of 37. We're looking for decimals, so we plug it into the calculator. When you add, you get one of these. When you subtract, you get the negative 1. Here, 12x squared minus 22x plus 6 equals 0. You might be tempted to immediately jump in and type in a is equal to 12, b is equal to negative 22, and c is equal to 6. But, and that actually would work. It would give you the right answer, and that's fine. But sometimes these things are a lot easier when the numbers are lower. And so there is a greatest common factor of 2. You can divide all the terms on both sides by 2 and get a simpler equation that has lower numbers. Just more reliable when you're doing calculations. So a is equal to 6, b is equal to negative 11, and c is equal to 3. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This simplifies to positive 11, and this simplifies to 121 minus 72. 121 minus 72 is 49, so it's 11 plus or minus the square root of 49. And the square root of 49 is 7. So 11 plus 7 over 12 is 3/2, and 11 minus 7 over 12 is 1/3. I'll bet you I could have split the middle on this one. I could have actually factored, because the numbers come out so nice, so you don't need to round. Yeah, you could. Let's see, 6 times 3 is 18, and factored pairs of 18 could be, you definitely could have split the middle on that one. All right, let's go. Projectile motion formula, h of t is equal to negative 1/2 gt squared plus v0t plus h0. Where on Earth, g is equal to 0, delete that, g is equal to 32 feet per second squared, or g could equal 9.8 meters per second squared, depending on what units you're using. Contest. At the World Championship Pumpkin Chunkin Contest, pumpkins are launched hundreds of yards from a platform that is 10 feet off the ground. I would love to see this. If a pumpkin starts with an initial upward velocity of 124 feet per second, when does it hit the ground? So we're looking for that t final when h of t is equal to 0. We're looking for that x-intercept, that 0. And that's exactly what the quadratic formula will give. What we know is that the h of 0 is 10 feet, the v0 is 124 feet per second, and the g value is 32 feet per second squared. Plug it all in, we get h of t. The formula is negative 16t squared plus 124t plus 10, and we want to know when is that equal to 0. So, since it's all set equal to 0, we go x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And there it is. Wow, there's going to be some huge numbers, and when you plug it all into a calculator and hit enter, you get something that's approximately 7.83 seconds, not equal to, approximately. Can you imagine a pumpkin in air for almost 8 seconds? What a ride. That would be awesome to look at. All right, so check this out. Diving. A diver jumps from a diving platform that is 10 meters high. She starts with an initial upward velocity of 0.5 meters per second, which is not that fast compared to a pumpkin. When will she hit the water? So we've got t of f and h of t is equal to 0. The initial height is 10 feet. Initial velocity is 0.5 feet per second, and these should all be in meters. And the strength of gravity on Earth is 9.8 meters per second squared. The height, therefore, is going to be negative 4.9 t squared plus 0.5 t plus 10 is equal to 0. Plug them in. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Plug them in, and this is what you get. Ignoring the negative value, it would be about 1.48 seconds. That's how long a dive takes, 1.5 seconds to perform a dive. I don't know how y'all divers do it. If you're a diver, let me know. I'd love to hear about it. We're going to solve this equation each way. So here's an interesting task. Take an equation, and we've learned so many different ways of solving quadratic formulas. What if we took one equation and we solved it multiple ways, just to illustrate what it would look like? Okay, so the first way would be to find the greatest common factor, x squared minus 16x equals 0. Greatest common factor is x, and you factor it out, and you get x is equal to 0. This part is equal to 0, and this part is equal to 0, using the zero product property. And then you add 16 to both sides, you get x is equal to 16. 0 is one solution, and 16 is another. Those are the two solutions. What would it look like if we were to complete the square? Well, we're taking 16, cut it in half, or negative 16 cut it in half would be negative 8 squared is 64. So what you would have to add to both sides is 64. Then we've arranged this, we've forced it to be a perfect square, and now you can factor it using the formula. We have x minus 8 squared is equal to 64. Taking the square root of both sides, we get x minus 8 is equal to plus or minus 8, and then you can say that x is equal, splitting the two equations up, you get x minus 8 is equal to positive 8 or negative 8. When you add 8 to both sides, you get 16, or you get 0, which are the two solutions. It's a little bit more complex, but I'm illustrating a point that you can solve the same equation multiple ways. And it's your choice as a student. If there's no instructions given, it's your choice as a student to figure out how you want to solve it. A equals 1, using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Eventually you get 16 plus or minus 16 over 2. When you add, you get 16. When you subtract, you get 0. Those are the two solutions. So I think we can all agree that this is easiest over here, but the point is you've got lots of options when you're solving quadratic equations. Now check this out. There's lots of different before you do, here's another point that I want to make. The big idea here is that there's going to be a lot of preliminary work that you could do if you wanted to use the quadratic formula. So the one thing you've got to do is you've got to solve it for 0, and because if you try and head straight to the quadratic formula with this, you might imprecisely put in a positive 2/3 as the c value, but really you got to solve for 0. That's required. The c value you can see here is negative. At the very least, negative 2/3. But honestly, it's going to be way easier if you clear those fractions. Can you imagine putting 8/3 and 4/3, negative 4/3, and negative 2/3 into the quadratic formula? Oof, that's rough. Why don't you clear the fractions? Multiply all the terms on both sides by 3. It's not required, but great studentship. Here's another thing you can do. Here's some more preliminary work. You can write it in standard form. You might say, oh, the a value is 8 and the b value is negative 4, which in fact, if you write it in standard form, that would be ax squared plus bx plus c is equal to 0. You can see it's a lot easier to see that this should be positive. That this, 8x is here, 8x is here, and then it really should be negative 4x squared plus 8x minus 2 is equal to 0. So the a value is actually negative 4. The b value is actually 8. The c value is actually negative 2. Here, and then one more thing that you can do if you want, good studentship but not required mathematically, is that you could factor out the greatest common factor. The numbers are kind of high here compared to what you could do if you divided all the terms on both sides by 2. So or even by negative 2. This would be negative, and this would be positive. So we get 2x squared minus 4x plus, and I'll let you figure out what that number is right here, what's underneath the red dot. So these numbers are way easier to plug in than all the others, and that's what I recommend before you jump straight to the quadratic formula. Do your preliminary work. Here, and check this out. You can see x. For this equation, you get a equals 1, b equals 3, c equals 3, and so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This would be 9 minus 12 is negative 3. So check that out. This is, again, one more reason why we had to do all that work with imaginary numbers, because sometimes when you get a negative inside the square root, that's what your answer is going to be. It's going to have an I. All right, thanks for tuning in. Thanks for paying attention and taking notes. Keep up the great work, and I'll see you in class.